Hello everyone. So I hope all of you are doing well. So today's section I am going to tell you about hybridization process, and in that and some types of hybridization means SP and SP2, SP3 and SP3D and SP3D2, SP3D3. Okay, with an examples overview about this is an overview about our mind mapping about hybridization process and their types. So now we see their geometry and structure means geometry or shape, or next electronic configuration we will see now. So this is a hybridization. First we will see definition of hybridization process. సో మనం దీన్ని తెలుగులో సంకరీకరణం అంటాము. సో జనరల్గా సంకరీకరణం నుంచి మనకు మూడుగా డివైడ్ అయి ఉంటుంది. దాన్ని మనం SP3 సంకరీకరణం లేదా SP3, SP2, SP3 అని అంటాము. జనరల్గా సంకరీకరణం ఎట్లా ఫామ్ అవుతుందో చూద్దాం. సో ద hybridization is how they are formed means it refers to the processing of the intermixing of an orbital is equal to near energy to distribute the new set of orbitals. This is called new hybrid orbitals. This process is called hybridization process. Okay, means one atom means one atomic orbital and another atomic orbitals, they are combined together to form a new set of orbitals, or it produces new set of orbitals that we call as hybridization. Okay, means ఒక ఆటము ఇంకో ఆటము ఆర్బిటాల్స్, రెండు ఆటమిక్ ఆర్బిటాల్స్ కలిసి ఇంకో కొత్త ఆటమిక్ ఆర్బిటాల్ని ఏర్పరిస్తే దాన్ని మనం సంకరీకరణం అంటాం. ఏమంటాం? సంకరీకరణం అంటాం. ఓకే, దీన్ని మనం సంకరీకరణం అంటాం తెలుగులో. నెక్స్ట్ in hybridization process, so it will divide as SP, SP2, SP3, SP3D and SP3D2 hybridization. Means beryllium chloride is the example of SP, and boron trifluoride is the example of SP2, and methane is the example of SP3 hybridization, and PCl5 phosphorus pentachloride is the example of SP3D, and sulfur hexafluoride or chloride, maybe halogen trihalogen compounds, and SP3D2 hybridization. Next iodine heptafluoride, or it may be whatever in place of fluoride we put on it, chloride also, D3. Okay, these are the types of hybridization here in the hybridization process. So now we'll see SP3 hybridization one by one. Okay, SP hybridization. So SP hybridization example is best example is beryllium dichloride. Next beryllium is a central atom, means I put now we see electron configuration of beryllium atom. So 1s2 and 2s2. Beryllium is atomic number is 4, right? So ground state electronic configuration, this is ground state electronic configuration. And now we'll say excited state, in short form ES. So 1s2 and 2s1. In here one electron jumps from here s 1s2s2 to 2p orbitals, 2px1 means 2px. Okay, these are the two set of orbitals, means one s orbital, two p orbitals combines to form 2sp. Okay, 2sp, these are new hybrid orbitals, right? Means this is a spherical shaped s orbital and p orbital, 2p orbital. It produces 2sp. Okay, 2sp. So here 2sp orbitals are produced. These are new set of orbitals. That means we will see now. So one s orbital plus 1p orbitals, it gives 2sp, right? 2sp orbitals. This is a new set of orbitals. Here some orbital structure of SP hybridization means here we have only two unhybridized orbital. We will see excited state. Okay, here I will show you orbital structure. Here this is a py unhybridized orbital. Here this is a pz. Okay, this is a pz. this is the px. Okay, pz both are py and pz is the unhybridized orbital. These are the hybridized orbital. Okay, the terminal side is the hydrogen here. This is a sp hybridization, sp. Okay, now we'll see the how orbitals are combined to produce new set of orbitals. Like I will show you now in the form of orbital structure here. So this is a pz. Okay, this is a px, this is a py, right, and this is a px, the another set of orbital. Okay, this is a pz and this is a py. Okay, these are the unhybridized orbitals. We don't need to go out this. Okay, we don't need to this. Next this is also pz, this is a py. Okay, this is a pz, px, this is the sp orbital. It form covalent bond here, and it will, they are unhybridized orbitals. They can form pi bond. So pi bond, this is a pi bond, this is a hydrogen, terminal side contain hydrogen. Okay, this is the sp. This is called sp hybridization, means 2 sp, it produces 2 sp. Okay, example ethylene also example, best example. When we see the molecules, we can easily name it. It may be sp and sp2 sp3, right? So here s, c and c and h. Okay, it can form a pi bond here, pi bond. This is a sp hybridization. This is a sp hybridization, means it will for example, still in example, it may be contain 3 bonds here. This is a sp hybridization. It may be 2 alkane. Alkane is the sp2 hybridization, and alkane is the sp3, right? This is remembering these 3: alkane on alkene, alkyne. Alkane always named as sp hybridization, and alkene always named as sp2, and alkane is always sp3 hybridization, right? Remembering these words what I am saying. Next we will see next structure of beryllium chloride. It taken some long time, but it's so bored, but I will say in easily understanding method, so we can remembering this hybridization process and types. So now the central atom beryllium, so we will see structure of this beryllium chloride. So shape is a linear and bond angle is 180 degrees. Shape is linear. Okay, this is structure remembering. Next we will see sp2 hybridization, right? sp2 hybridization example is we'll close within the 30 minutes. So example is boron trifluoride or boron trichloride, whatever. So now central atom is boron atom. So electronic configuration is 1s 2. Boron atom is atomic number is 5, 2s2 and 2p1 here, 2p1. Okay, now we'll see ground state electronic configuration and excited state electronic configuration, and next hybridization state, right? Now this is a ground state in the form of gs I will write, and es and hs, hybridization state. Okay, here energy level 1s 2, 2s2 and 2p1. Okay, 2p1, here 3 and here 2, here 2. Means every orbitals can carries, or it took up the only 2 electrons whatever the orbitals have. So here 2 and here 2 and 1. Okay, this is the ground state electronic configuration, and we will write excited state. Here no space, so I will write only free electrons like, okay, without orbitals. So now here 2s2 orbitals, one electron jumps from the p orbital. So one electron jumps from the p orbital here in excited state. Only one here 2s2, here only 2. Okay, next here don't need to write this, and only lowest energy means 2s orbitals. Then here electrons can jump from the p orbital, 1s2 to 2p1. So here can form 3 orbitals, 3 set of orbitals. Here 3 sp2, okay, 3 sp2 hybrid orbitals are formed. Okay, this is an example for boron trifluoride. Okay, and how they are in the form of orbital structure. So this is unhybridized orbital is PZ, unhybridized orbital is PZ only, and here only hybrid orbital are here sp2 and sp2 and sp2. Okay, and this is also another orbital structure. This is also a PZ orbital, unhybridized orbital here. Okay, these are the, this is also sp2, this is also sp2, only one unhybridized orbital. It forms pi bond here. It will form pi bond. Okay, it will form pi bond, right? Pi bond. So you can easily understanding. So we have less time, so now go ahead. So now next structure of sorry, before this, before we going to structure. So now sp2 hybridization means the mixing of one s orbital plus 2 p orbital. It produces 3 sp2, right? Already I told you this, remembering this word, this simple method. Okay, now structure of now we will see structure of boron trifluoride, right? Boron trifluoride. This is the central metal atom boron. Here fluoride atoms, here one fluoride atom. So it will, the structure is trigonal planar, shape is trigonal planar, and bond angle is 120 degrees. Okay, bond angle is 120 degrees. Next we have sp3 hybridization. Okay, sp3 hybridization means example is methane. Best example is methane. Okay, methane. Next, now we'll see ground state electronic configuration. I will see ground state. Carbon ground state is here 1s2 and 2s2 and 2p2, right? This is a ground state electronic configuration. So p orbitals, it may have 3 pairs. It is equal to 6 electrons, and s is equal to 2, only 2 have. And next d orbitals, it may have 5 pairs, is equal to 10 electrons. Okay, and in case of f orbital, we have 7 pairs and is equal to 14 electrons, right? Remembering this is the ground state of carbon atoms, and this is the excited state of carbon atom, right? Here 2, and here also 2. Okay, now excited state means in the 2s2 electrons is jump from the here 1s, means here excited state form 3 and here 1. So these 4 are combined together form 4 set of orbitals. 4s2, 4 sp2 orbitals are formed. Okay, 4 sp3 orbitals are formed. Okay, here there is no unhybridized orbitals. Here 4 sp3 hybridized orbitals are formed. Okay, now sp3 hybridization means 1 s orbital and 3 p orbital is equal to 4 sp3. Okay, 4 sp3 produces new set of orbitals, right? Next structure of next, now we'll see orbital structure. So here 4. Okay, 1, 3 and 4. So here only we have sp3 and sp3. Okay, this is also sp3. Now another form is here carbon atom have 4 bonds, 4 valency electrons or 4 tetravalency carbon. It has hydrogen, terminal hydrogen here. So the bond angle is 109.5 degrees. Okay, bond angle. Shape is tetrahedral, right? Tetrahedral shape. This is structure of carbon means sp3 hybridization. Next, now we'll see this difficult interhalogen compounds, that is sp3d2, sp3d. First one is sp3d hybridization. Mostly in this section means in this part, the involvement is d orbital here. Involvement of d orbital. Okay. First sp3d example is phosphorus pentachloride or phosphorite pentafluoride. Okay, phosphorus pentafluoride is the best example of sp3 dihybrid orbital. Now we'll see electron configuration of PCl5. So in here central atom is phosphorus. Okay, phosphorus. So electron configuration of phosphorus, electron atomic number is 15. Okay, 15. Now we will write 1s2, 2s2 and 2p2 and means 2p6. Okay, 2p6 10 here, and next 3s2 and 3p1. Okay, 10 and 13 means 3p4, no, 3p3 is correct. Okay, 3p3, 1s2, 2s2, 2p6 and 3s2, 10 and here 15. Okay, 3s2 and 3p3. Now we will write means ground state configuration and then after and excited state. Okay, here ground state of phosphorus, here 1s means 3s2, 3p5, no 3p4, 3p3 here. Okay, 3p3 here, 3d is 0. Okay, 3d vacant or d orbital is 0. Now excited state of phosphorus here, so here 2 and here 3. Okay, here no space, that's why I will write in the form of electron symbol. So here vacant 0. Now excited state here 3. Okay, here one d orbital goes to here, means p orbitals here 1 in s orbital, 3s2 it jumps from the d orbital, 1 d orbitals. Okay, this excited state means to produce hybridized state. Okay, when they are combined to form, it produces a hybridized state. So 1 2 3 4 5 6 here, so 6 means sp3d. Okay, sp3d, this is the sp3d means 6 sp3d are formed. Okay, for example in sp3d hybridization means 1 s orbital plus 3p orbital and 1 d orbital is equal to what? It carries means here 1 and it produces 6 sp3d, 6 sp3d. Okay, or means sp3d will form, sp3d hybridization will be produced. Okay, when we write this, next structure, and now we will see electron configuration of sp3d already completed, and next structure of sp3d. Okay, structure of sp3d. Here example is already told you, phosphorus pentachloride PCl5. The shape is trigonal bipyramidal. Okay, trigonal bipyramidal. Here this will be trigonal bipyramidal, or shape is trigonal bipyramidal, and bond angle is 120 degrees or and 90 degrees here. Now structure is PCl5, here phosphorus central metal atom, here 3, and bipyramidal means 2 orbitals here. So here F and in place of F we put chloride. Okay, fluoride. This is a trigonal bipyramidal, bond angle is here 90 degrees and 120. Okay, this is the structure of PCl5 and shape is trigonal bipyramidal. Okay, now next we will see sp3d2 hybridization. Okay, sp3d2 hybridization means 1 s orbital plus 3 p orbital and 2 d orbital. Okay, it will form sp3d2. sp3d2. Okay, example is SF6 sulfur tetra means sulfur hexafluoride. Okay, sulfur hexafluoride. This is the example. Central metal atom is sulfur. Atomic number is 16. So we will write now electronic configuration of sulfur. 1s2, the short form 3s2 and 3p4. 3p4. Okay, 3p4, 6 is balance. Now we will see ground state of sulfur and excited state of sulfur and to produces hybridization state. Okay, hybridization state. Now ground state of sulfur, here 3s2 and 3p4. Here only 3d0 vacant here orbital, so here no space, but I will write in the form of electron. So here 0 in a ground state, here 4, here 4. Okay, here 2. Next in excited state, it will form the 3s orbital contain 1 electron goes to d orbital. Okay, here 4 and here 1. So it may be it carries 6 also. It has 6, produces sp3d2. Now we will see structure of SF6. The structure is octahedral shape. Okay, octahedral shape. Here fluorine, here fluorine, here fluorine, here fluorine, here fluorine. Okay, this is octahedral shape. Bond angle is 90 degrees. Okay, 90 degrees. And finally final hybridization is sp3d3. Example iodine heptafluoride, best example. And sp3d3 hybridization means 1 s orbital involvement and 3p orbital and plus 3d orbital to give sp3d3. Okay, now we will write the electron configuration of IF7. Iodine is the central atom, so in the then electron configuration is 5s2, 5p, 5p5. Okay, 5p5, 7 is balance. Now ground state of iodine, here 5s2 and 5p5 and 3d0. Okay, 3d0. Now here 2 and here 5. Okay, 5. Next here 0 in the ground state. And then next in excited state, 1 s orbital and 5 s orbitals contain electrons is goes to d orbital here, and here 4, here 5 and here 2. So it will form 7. Okay, 7 sp3 d orbitals. 7 sp3 d orbitals will be formed. Okay, sp3 d3 will be formed. Okay, this is the sp3 hybridization, sp3 d3 hybridization. And next geometry. We will see the geometry of IF7. Okay, IF7 structure of IF7 is pentagonal bipyramidal shape, and bond angle is 72 degrees centigrade. Okay, or sometimes 90 also angle is. Now will I show you structure of IF7. Here I, so not space here. Okay, structure of IF7. Here the pentagonal bipyramidal IFC. Here bond angle is 72 and 90 here. Okay, 72, 90. This is a pentagonal bipyramidal shape, and bond angle is 72 degrees or 90. Okay, finally I hope all of you are understanding well about this concept, organic concepts, about the process of hybridization and types and their geometry and shapes and their electronic configuration. So finally, thank you all who are watching this my video.